Alright, so looking at today's lesson, we are going to be focusing on angles in polygons, starting 8.2 in our chapter. Looking at our objective for today, it's going to be find the measures of interior and exterior angles of polygons. The very first note I want you to write down here today is going to be the polygon angle sum theorem. Please write down the bottom piece of this. Don't worry about the top. I'll read through the top right now. But just focus and write down in your notes that bottom piece. It says in each convex polygon the number of triangles formed is 2 less than the number of sides, which is used by the variable n. So the sum of the angle measures all of these triangles is n minus 2 times 180. Essentially what you are going to be doing with this polygon angle sum theorem is you are going to be breaking up this polygon into the total number of triangles it is made up of. Okay, and we know that the triangles are going to be all have the sum of, or their interior angles have the sum of 180 degrees. And that's why we multiply times 180 degrees. You're taking the total number of sides, that's what your n is, n minus 2 times 180 degrees. That is our polygon angle sum theorem. So take a moment and write this down. It says find the sum of the measures of the interior angles of a convex nonagon. If you think you know how to do this, please pause this, take a look, and give this problem a shot. Again, it says find the sum of the measures of the interior angles of a convex nonagon. Well, the very first thing I'm going to ask you is going to be this. What is the number of sides a nonagon has? If you said 9, absolutely. If you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. A nonagon has 9 sides. So essentially what we're going to do is we're going to take that 9 and plug it into our equation of n minus 2 times 180. We're going to plug that 9 in for our n because n stands for the total number of sides, and multiply it. Break it down into 7 because 9 minus 2 is 7, and multiply it times 180, which if you do that, you get 1,260 degrees. What that means is the entire measure of all convex nonagons are going to be 1,260 degrees. All convex nonagons. Again, we have another example. On this one it says find the measure of, whoops, that's supposed to be angle A, not quadrilateral A. Angle A in the diagram. So if you look up here, if you know how to do that or have any idea how to do that, please give it a shot, give it a try, pause now, and do that. So looking up here, it says find the measure of angle A in this diagram. What you have to do, the very first thing you have to do is you have to figure out first of all, what is the total sum of this polygon. This polygon is going to be a hexagon. We know a hexagon has 6 total sides. So if it has 6 total sides, we can plug that in to our equation of n minus 2 times 180. 6 is going to go in there. We're going to solve then. We have 4 times 180, and if you multiply 4 times 180, you will get a total of 720 degrees. Okay, so this hexagon, and actually all convex hexagons, have a total measure of 720 degrees. So what we're going to do is, we know that the entire sum of this shape has to be 720 degrees. So we're going to add all of these individual angles up together and see how that matches up with 720. So you will get x plus 137 plus 141 plus 117 plus 100, and lastly 120 equals 720 degrees. If you can do quick math in your head, add all this up, or use a calculator, I guess. Add that up quickly, you will get x plus 615 is equal to 720. Essentially, what I just did is I just added up all the angles that I know, and I'm going to solve for x, which represents angle A. Subtract 615 on both sides, subtract 615 on the right side. X is going to equal 105 degrees. So that I know that angle A is going to be 105 degrees. Here is my answer. All right. Now it says find the measure of an angle, or of an interior angle of a regular pentagon. A regular pentagon. Here's that key word. Try to figure this one out on your own. Pause the video now and solve. All right, let's see if you're right. So if you look here, we have a regular pentagon. If you think to yourself, that word regular, what does regular mean? Equilateral and equiangular, meaning they all have the same side lengths and they all have the same angle measures. So if we know we have the same angle measures, we can easily figure out what each angle is going to be. The very first thing we have to do to get through this process is absolutely, you got it. We have to do n minus 2 times 180. Get used to that formula. You're going to need to know that and use that a lot. All right, so we know a pentagon has 5 sides. Plug 5 in there and solve. Once you solve, you will notice that it is going to be 540 degrees. The entire measure of this regular pentagon is 540 degrees. Now, this being a regular pentagon and it being equiangular, we can label each of these angles as x. So if I put this one x, 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 we don't know what their angle measures are, but we do know that we have all of them are going to be the exact same. So if you add all of these x's up together, I'll take this step, add it up, equals 540 degrees. We know all of these x's can be combined to get 5x is equal to 540 degrees. We're going to solve for x by dividing 5. X is going to equal 108 degrees. So each of these angles of a regular pentagon are going to be 108 degrees. Nice job. Okay, you don't have to write this one down. As you see, there is no yellow bar up here. Don't worry about writing this down. All I'm going to do is I'm going to read through this and kind of show you what I'm talking about as far as exterior angles. It says, in the polygons below, an exterior angle has been measured at each vertex. Notice that in each case, the sum of the exterior measures is 360 degrees. Okay, if you look here on this graph, you will notice that we have our initial triangle, okay, right there, and you will also notice that we have an extended side. Okay, this extended side gives us, each extended side gives us an angle measure. That's going to be known as your exterior angles, the angles on the outside of each vertex. Okay, again, over here on the right, you will notice we have a pentagon. Doesn't look like a pentagon, but it is. Okay, here is our wonderful pentagon. 3, 4, 5. And we have our extended sides on each side, giving us exterior angles of 41, 55, 110, 43, and 111. Notice that if you look at both of these shapes, I'm going to break this, break that up. Okay, you will notice that every single shape, at least these two shapes, and it's going to be true for every single shape, their exterior angles are going to add up to be 360 degrees. Notice we have 360 degrees on a triangle. On a pentagon, something with 2 more sides, we still have 360 degrees. What that tells us, our polygon exterior angle sum theorem. Please write this down. It says the sum of the exterior angle measures one angle at each vertex. Again, if you slide back to that last slide, or go back to that last slide, you will see that one angle, there's only one angle at each vertex of a convex polygon, is going to be 360 degrees. Please write this down. Pause now if you need extra time. Alright, so moving on. Here's going to be our last note of the day. It says, find the value of r in polygon JKLM. Very original. Look at that, JKLM. Okay, so looking up here, you will see that we have exterior angle measures of 4r, of 7r, of 5r, and 8r. I do want you to notice that if you kind of when you draw exterior angles, they all kind of go in the same way. So you could say it's either clockwise, counterclockwise, whichever. If you notice that it's going to always kind of go around in a circle, meaning here's one exterior angle there, this keeps going this way. Alright? If that kind of helps you with exterior angles, they just kind of point out at each side. Now, find the value of r in the polygon. We know that the sum of all the exterior angles will always add up to be 360 degrees. Okay? So, now knowing that information from that previous side, pause now to see if you can find it. Alright, so looking here, it says find the value of r. So what we are going to do is we're going to find the sum. Sum meaning we're going to be adding them up and equaling 360 degrees. So we have 4r plus 7r plus 8r plus 5r, and that's going to equal 360 degrees. Alright, when we add all of these up, you can add them up. You're going to get 24r is equal to 360 degrees. Solve for r here, divide by 24 on each side, and you will notice that r is equal to 15. Okay, so now what we know about exterior angles is that all exterior angles, when added together, all exteriors of the same polygon, when added together, will equal 360 degrees. It doesn't matter if it's going to be a triangle or if it's going to be a nonagon or an octagon or a 13agon. Doesn't matter, they will always add up to 360 degrees. That's all our notes for today, and we're done. Nice job, guys.